Okay, this is chapter 2.9. This section we'll be looking at solving percent problems using proportions and percent equations. And we'll show you situations on when to use one over the other. On this slide, I want you to write down, oops. I want you to write down this part. So basically what that's saying is that percents are good because they put everything in a base of 100. And so when you're talking about like 50%, you're talking about 50 compared to 100. If you're talking about 70%, it's 70 compared to 100. And it puts it in the same base as everything else that you're talking about. You're not talking about 7 out of 10 one place and 5 out of 20 in another place. It's all out of 100. And so that's why percents are pretty useful. Okay, on this slide, we want you to get that header, and then we want you to have all of this and all of that part, and then this part, and that part. And as far as this visual, the picture, that's kind of up to you. If that helps you, you can sure write it down. If not, I wouldn't worry about it. The biggest thing that it shows is it compares like an actual number to the percentage. So if the base is 50, 50 is considered 100%, 0 is 0%. If the base is 50, 25 would be considered 50%. So again, if that helps you, write it down. If not, don't worry about it. Go ahead, pause your video, write all that down. Okay, so what this is saying is A is P% of B. And what that means is that B is going to be your base. And so when you compare A to B, the p-value is going to be your percent. So how much of B is A? So make sure that you pay attention to what A represents, what B represents. B is always your base. A is what's called the part. Okay? This algebra portion, so this is the proportion kind of view of it. So if we're comparing A to B, that'd be like comparing the percent to 100. Okay, because remember, the percent base is always 100. And we're comparing something to whatever the new base is. So here, we're comparing 25 to 50. 50 is the base. And we're trying to set it equal proportionally to some value over 100. And if we were to just to cross multiply these, you would get 50p equals 2,500. And if you divide by 50, P is going to equal 50 percent. So let's set the second one up. What percent of 56 is 42. So the of 56, so that tells you that 56 is your base, 42 is the part. So we're going to say 42 equals, and you can use any variable you want. You can use p like they did, you can use x, and we're going to put it over 100. And if we cross multiply, we get 56p equals 4200. And if we then divide by 56, you get p equals, sorry, I'm not sure what happened there, p equals 75%. Let's try another one. What percent of 90 is 54? So 90 is your base, 54 is the part, we're going to use any variable again, so we can use x over 100. Sorry, I'm not sure what's happening with my little tablet right now. But we cross multiply and we get 90x equals 5400. And when we divide by 90, the 90s cancel and we are left with x equals 5400 divided by 90, which is 60%. So 54 is 60% of 90. On this slide, we want you to put down that, all of this part, okay, sorry about that. I had a little issue with my tablet. Hopefully we're back. Which we're not. Let's try one more time. Okay, we want you to write down this part and all of this and all of this and this down here. And again, the model over here is optional. So go ahead, pause, and put that in your notes. Okay, so what this percent equation is good for, it's still a model of it's still representing the same type of stuff, but it's kind of situational. So we'll show you a situation here in a second where it's used pretty more effectively for. But it's still the same situation where A is your part, P is your percent, and B is your base. Okay? So if we were to say 25 is P% of 50, we would write it this way, and we would just solve for 50. So it would look a little something like, we would divide that by 50. And divide that by 50. And when we did that, we would get P equals 0.5. I apologize for my tablet. It is just not working right, but we'll do the best we can. What you have to realize is that 0.5 is actually 50%. So you have to make sure that you make that change in your head. Okay? Okay, so let's try this. Using that percent equation, what percent of 40 is 2.5? So what part is first, 2.5 equals P times 40. So we're multiplying by 40 right now, so we're going to divide by 40, which means P equals, so now if we take 2.5 divided by 40, we get we get 0.0625. Like I said, you have to remember that this is a decimal right now, and you have to change it to a percent. So the way you change it to a percent is move the decimal over 2 places. So that is actually 6.25%. So that means 2.5 is 6.25% of 40. Here's another one. We're going to show you both of them side by side and see which one you kind of like better. What percent of 84 is 63? So if we were to do this using the percent equation, 63 is the part, '84 is the whole, divide by 84, and we would get P equals 63 divided by 84, which is 0.75, which comes out to be 75%. Now if we did this using a proportion, we would have 63 over 84 equals P over 100, and we would cross multiply. So we would get 6,300 equals 84P. Divide by 84, and we would get P equals 75, which we know is already a percent. So it's the same concept, 2 different ways. You kind of pick whichever one you like best. Okay? And that's where we're going to leave off for this video. I apologize for the tablet not working very well and my writing being all over the place. But write down any questions you have, and we will take those questions in the morning.